I'm Uni Junk, and this is my Lab 5. The purpose of this lab is to model Felix's freefall using physics principles and approximations in GlowScript. The main result is that Felix broke the speed of sound and was supersonic. And for the procedure, I used the website given to get the initials, and then I used the initials to estimate a drag coefficient. And lastly, I used the drag coefficient and the initials to create a GlowScript model to model a similar scenario with drag. This is the process of making my GlowScript model. Using the website and the internet, I was able to get that the initial position is 36,576 meters, and the initial velocity is 0 meters per second, since we assume that Felix is starting from rest. The mass is Felix plus the suit, which is 73 plus 31.75 kilograms, which is 104.75 kilograms. The time that Felix was in the air is 228 seconds, and his maximum speed is 376.97 meters per second, and the speed of sound is 343 meters per second. Drag force depends on the drag coefficient and the square of the object's speed. The negative symbol indicates that the force always acts in opposite direction of the object's velocity. Velocity can also be determined with the data obtained. Since velocity only has a vertical component, drag force can also only have a vertical component. To find the proportionality constant, I used my knowledge on net force, gravitational force, and drag force. Since gravitational force plus drag force must equal net force and the formulas for gravitational and drag force are given, B can be found. With the initial velocity, time, mass, and change in position, net force can be found. And my B was 0.0358726. In my GlowScript model, I inputted the initial position, initial velocity, and ball mass. Then, I defined gravitational force, drag force, and net force. I also used Newton's second law and the position update formula to update the ball's velocity and ball's position. These are the graphs from the GlowScript model. The first principle of this lab is that net force is the sum of all forces acting on the system. In this lab, the system is a skydiver. The surrounding is everything that interacted with him, like the air and the earth. The forces acting on the skydiver is drag force, which is also called air resistance, and gravitational force. Some other principles that are used is the momentum principle and the position update formula, which were used in the GlowScript code to determine the predicted y position with respect to time. Here's my discussion. There are numerous potential sources of error in this experiment. For example, the drag coefficient may not portray the actual situation because it was estimated. There also may be other forces that I did not take account of, such as spin. The mass of Felix is also estimated based off the information online, so it may not be true to the situation. And also, Felix is not a point mass, so there may be rotational kinetic energy. The first question is, what if Felix was dropped at a lower height? And using the energy principle, I calculated that Felix must be dropped from a height greater or equal to 6,002.5 meters if he wanted to reach the speed of sound. The second question is, how would Felix's terminal velocity change if he altered his body's orientation? And using the formula 1/2 times density of fluid, which is air in this lab, times velocity squared times drag coefficient times reference area, which is the area of the object that's facing the direction of motion. Therefore, if A is greater, drag force is larger. And since drag force opposes motion in this lab, having a lower reference area will increase Felix's terminal velocity. In conclusion, I modeled the motion of Felix as he tries to go supersonic in this lab. By estimating the drag coefficient, calculating net force, and updating the position and velocity, I was able to simulate his motion. The model predicted that Felix's speed will exceed the speed of sound. However, due to potential errors like inaccurate estimation of drag coefficient, this model may not portray the actual motion of Felix. But overall, this lab showed how computational models could be used to model real-world situations.